All right, friends, we're going to continue these notes. So I think what notes we are building off of are the 3.1 to 3.2. I think we should maybe put an A in here for usefulness because it's two videos. So 3.1 to 3.2A. So now what I want to do is I want to call this 3.1 to 3.2B vocab, okay? That's what this video is going to be titled, okay? So that's what we should be kind of talking about. And there were a couple of vocab words that we did not wrap up on the last one, which were, I think, discrete and continuous. And I want to talk to you about discrete and continuous. They're pretty straightforward terms. It's pretty basic. I want to ask you a couple of things, okay? When I talk about discrete and continuous, I think the most simple way to understand it is the following. Milk, oh, this is not a good drawing. Milk is continuous because when you have a glass of milk, it like continuously fills up, right? It like, you measure it, right? This is continuous. But eggs are discrete. Eggs are discrete. So we have an egg, have another egg. Okay. Eggs are discrete and milk is continuous. Does that make sense? I can't get the well, you know what it says. It says Mick. Okay. So eggs are discrete and milk is continuous. So now let's talk about some other things that are discrete or continuous. So here's the continuous bubble, and here's the discrete bubble, okay? Where would you say chickens go? Do chickens get counted or measured? Yes? Discrete or continuous? Discrete. Chickens. I agree. Chickens are discrete. You count them. You don't have 3.5 chickens. That's not a thing. Okay. Is concrete, is that discrete or continuous? Concrete. Cement, concrete. Yeah, I would say concrete is continuous. Is gasoline discrete or continuous? Continuous, I would agree with that. Continuous. I guess if we had to make a very specific definition of discrete and continuous, we would need to look, and I would try to like maybe base it off of the book.
Are we supposed to be like writing this right now?
I would, yeah. I would say that discrete is a type of domain where you count the numbers, where you count. And continuous is, I would say, a type of domain, I guess where you measure. I would say that's probably the best way to look at it, okay? So concrete is continuous. What about floor tiles, like the tiles on the floor? Are they discrete or continuous? Discrete, yeah, you count the tiles that you need and you go get them. So I would say tiles are discrete, okay? Can somebody give me another example of discrete or continuous? Just pick something and tell me what you think it is. People are discrete. What's that? A house is discrete, I would say. So a house is probably discrete, and people are also discrete. What's something else that's continuous? Give me one more continuous thing. Anybody? Yes?
Track.
A track? That's a tricky one. What's that? Yeah, most liquids are continuous. That does help. Continuous is also like something like, oh, your height is continuous, isn't it? Your height. Yeah, because think about your height. You can count how many feet you are, but isn't it true that one person can be 5'1", and the other would be 5'1.1", and the other one would be 5'1.001", and the other would be 5'1.03", and the other would be 5'1.093", right? Isn't that true? Isn't that true? Okay. So then I guess I can say one more thing. This is kind of a weird thing to say, but are shoe sizes discrete or continuous? Discrete. I would say that shoe size is discrete. You don't get to choose. You just got to pick a size, right? But what about your foot size? Is it discrete or continuous? It is. So that's what's awkward, because your foot size is continuous and the shoe size is discrete. So what might you be in between sizes, right? Well, does your foot just automatically go from a 6 to a 7? Well, you'd measure it. You'd measure the length of it, right? That's why you put it in that thing. I put shoe size in discrete because you can either get a size 6 or a size 7 or a 7.5. No, because you can't get a 7.25 or a 7.125 or a 7.16 or a 7.03, right? So even if you get a 7.5, it might be too snug, right? And if you go up to the 8, it might be too big. So people get gypped with the shoes because the shoe sizes are discrete, and your body size, your foot size is continuous. That's a difference. That's why some people are wearing a 5 and they can hardly fit in it, but they know a 6 is too big because the shoe size is discrete. They're not going to make infinitely number of different shoe sizes. They're not like custom made. And that's discrete versus continuous, okay? That's important. So let's look at one more example of discrete versus continuous and see if we can understand it a little bit better. So like when you look at these right here, for example, you can see that this is a discrete domain because there's 1, 2, 3, 4, 5 different points. But how many points can you put in between here? So many. So it's like liquid. You see how it's kind of like that? That's a continuous domain versus a discrete domain. So what we want to do is talk a little bit about discrete and continuous. So here is another option. This function represents the cost of tickets for a museum. Each customer can buy a maximum of 4 tickets. Is the domain discrete or continuous, and find the domain? So what do you have choices over? Do you control the cost or do you control the number of tickets? Do you control the cost or do you control the number of tickets? Number of tickets. So why don't we list out the domain? How many tickets can you buy if you hate this show? You literally hate it. How many tickets? Oh, great, 0. Yes, perfect. Okay. Now, let's say you live a very lonely life, okay? And you just need to stay entertained, but you have 0 friends. How many tickets can you buy? 1. That's a choice. That's a choice. Great. Okay, shh. Let's say you are dating, okay? You're dating one person, okay, by the way. All right? And you decide to go to the show. How many tickets would you need to buy? 2. Wait, why not 1.5?
Because that's not possible.
That's not a thing. That's not possible. Okay. 2. Okay. Shh. Okay, great. Now, your friend calls you up. You're going on a date, but they have nothing to do that night, and you feel bad. So how many tickets are you going to buy? 3. Great. Okay. And now, listen, shh. It's much later in your life. You're old, and you've got a couple of kids. How many tickets you buy? You're old. You're married. You got some kids. 4. Okay. All right. Shh. Hey, we're recording right now. Everything that you're saying right now can be used against you. You know.
Hi.
That's right. This is all. Yeah, exactly. So everything you do and say can and will be used against you in a court of law. Okay. So, yeah, don't make me do that. All right, so listen, people. Is it a discrete or a continuous domain? Is it continuous, the number of tickets you buy, or discrete? Is it like your foot size or like your shoe size? Is it like milk or like eggs?
It's like discrete.
It's discrete, you're right. The domain is discrete. Good job. Because you can't buy half a ticket or a quarter of a ticket. You're not going to say, hey, I'd like 3.8 tickets, please. That doesn't really work, right? 3.8 tickets. So that's the deal. And then they were going to ask you to graph the function using its domain. I want to save some time, so I'm going to skip that. I want you to understand the basic idea, so I'm not going to do that part right now. What I do want you to do is look at this thing right here, okay? And I want you to focus on part A. How do we do on time here? Perfect. Oh, we're perfect. I want you to read this problem. I want you to pause the video, and I want you to try this problem. You're buying a bunch of DVDs. You don't really have to do part B. I wouldn't mind it if you did part B, but I really want you to do part A, okay? So you can either graph the function by making a table, but what's most important is to determine the domain of the function, the option, and to determine if it's discrete or continuous. You're buying DVDs. They're represented by the letter D. You have a limited amount of money, so you can't buy 5 million DVDs or you will be broke. Okay? You don't have enough money to buy 5 million DVDs, right? You can't buy 5 million DVDs. So think about how many DVDs you could buy. Let's say you hate movies, or let's say you love movies. What's the most you could buy in this function? Look at this function. Okay? There's a certain amount of money you have. Pause the video, give this a shot, especially explain discrete or continuous domain. Good luck. I guess we'll wrap it up here, so I'll see you guys soon. Peace.